Welcome back to EC TechNest. Another important question in the digital image processing most commonly asked in the exams would be explain the components of an image processing system. So don't confuse between the fundamental steps involved in image processing and components of an image processing system. So this is the components of an image processing system diagram, in which the computer is connected to a network. The computer is further connected with the image display, mass storage, and image processing software and hard copy, along with its connection to specialized image processing hardware and also image sensors. And the starting of the components of image processing would begin with the problem domain and then continue towards the network. We'll discuss about each block in detail. So the first is a physical device which is sensitive to energy and is radiated by the object. The second is called a digitizer. A digitizer is a device that is used for converting the output of a physical sensed device into a digital form. For instance, in a digital video camera, the sensors produce electrical output proportional to the light intensity. The digital converter converts these outputs to a digital data. Digital data would be in the form of zeros and ones. Next is we use specialized ALUs. ALU refers to the arithmetic logic unit, which performs arithmetic and logic operations in parallel on the entire image. Example would be a zinc processor which has a dual arm cortex which is programmable with the FPGA. Next one is computer. Computer used in an image processing system is a general purpose computer and which ranges from a PC to a supercomputer. Software. Software consists of specialized modules that perform specific tasks. And next one is mass storage. Mass storage is a must for image processing applications, and an image of size 1024 cross 1024 pixels with 8 bits for intensity representation requires 1 megabytes of storage. Storage is further classified into 3 categories, that is short-term storage and online storage and archival storage. Short-term storage is similar to temporary storage, whereas online storage is relatively faster and we can access it within seconds. And in archival storage, it is a type of storage where we have infrequent access. We don't use that normally, but we use that storage occasionally. Next is one method for providing short-term storage is computer memory. It has frame buffers that stores one or more images and can be accessed very rapidly. Frame buffers usually are housed in specialized image processing hardware unit. Online storage. Online storage generally refers to the form of magnetic disks or optical media storage devices. The key factor characterizing online storage is its frequent access to the stored data. Whereas in archival storage, it is characterized by massive storage requirement but infrequent need for access, such as magnetic tapes and optical disks. Next one is image display. Image display are mainly the output devices in which we see the output. Example would be TV monitors. Monitors are driven by the output of the image and also has graphic display card. Hard copy. Hard copy devices are used for recording the images such as the laser printers, optical character reader, and CD-ROM disk. Networking. Networking is essential and is a default function in any stream to perform communication, and also large amount of data can be transmitted through networking. So the next one would be applications of digital image processing. Digital image processing is used in various fields such as in human beings, it is used in the elements of visual perception. This is this diagram or cross section of the human eye, and the major part taking place in the digital image processing in human beings would be rods and cones. Rods are sensitive to low light, whereas cones detect the colors and work in bright light. Image formation in the eye. This is the example of image formation in the eye. Next, we'll discuss about the problems or the numericals that this module has. So the first one would be relationship between pixels. So there are three types, that is M adjacent, 4 adjacent and 8 adjacent. So this is the pixel diagram. The middle part, that is where the axis has 0, 0, where the axis has 0, 0, we name it as x, y, and where the axis has 0, 1 and 1, 1 as well as minus 1, minus 1, we keep on moving the axis values. So here it is x plus 1, y. Here x plus 1, y plus 1, x, y plus 1, x, y minus 1, and it keeps on increasing as the pixel values keep increasing. So the next one is 4 neighbor of a pixel. 4 neighbor of a pixel is the pixel values having either horizontal or vertical neighbors. Here x and y has neighbors, 4 neighbors, that is x plus 1, y, x, y plus 1, x minus 1, y, x, y minus 1. Here there are 4 neighbors, and in N4 or 4 adjacency of a pixel, we consider only the horizontal or vertical neighbors. And it also has 4 diagonals of a pixel, 4 diagonal neighbors in which we consider only the diagonal elements, that is x, y has 4 diagonal neighboring elements, that is x plus 1, y plus 1, x plus 1, y minus 1, x minus 1, y minus 1, and x minus 1, y plus 1. Together, when we combine the horizontal and vertical neighbors along with the diagonal pixels, we have the N8 or the connectivity or adjacency pixels. In 4 adjacency, we only consider the horizontal and vertical neighboring elements, whereas in 8 adjacency, we consider the diagonal neighboring elements. The 4 adjacency has the highest priority as compared to the 8 adjacency. Whenever there is a case where you can apply both 4 adjacency as well as 8 adjacency, in that case 4 adjacency has the highest priority. The third one is mixed adjacency. Mixed adjacency means the combination of 4 adjacency and 8 adjacency. Also, the distance measured between the pixels can be found out by using 3 different distance properties. The first one is Euclidean distance. Euclidean distance is represented by dE as a function of P and Q. Here you can see P has coordinates x and y, whereas Q has coordinates s and t. The Euclidean distance is calculated by the formula x minus s the whole square plus y minus t the whole square. The Euclidean distance has the formula square root of x minus s the whole square plus y minus t the whole square. And next one is called the city block distance, which is represented as d4 of p, q. It is obtained by considering modulus of x minus s plus modulus of y minus t. The next one is chessboard distance, also called as the d8 distance, and it is represented by d8 of p, q, and it is found out by considering maximum of modulus of x minus s, modulus of y minus t. Whichever is maximum, it is considered as the chessboard distance. And the properties of the D block would be the D of P, Q should always be greater than equal to 0, and D of P, Q is 0 whenever P is equal to Q.